Hello and welcome to another lecture of this course. As per name, this lecture is all about contents of whole course we will be learning. Con- Key contents of the course as mentioned in previous lecture are as follows: key binding systems, achievement systems, video and audio players, 2D and 3D animations, ninja side scroller game, menu animations, augmented reality video player, augmented reality app development using Vaporia, augmented reality food menu app for restaurants. In this video, I will try to explain a bit about every content so that your mind starts accepting reality of Unity 3D. You don't need to worry about the terms right now. Just try to understand the basics of every content and then we will move towards every content separately. I will try my best to show you the best examples regarding every content. So let's start with the very first one, key binding systems. It is also termed as character controllers. I can relate here a very common example of how many of us used to play games in which we pushed an up arrow button and our player jumped. Or we can say character W on a keyboard is for jump up, character A is to move a bit to left, character X is to move our player in bending position, and character D is to move it to right. We are literally going to learn this key binding system in Unity 3D further in this course. And there are two methods to move a player in C#. A simple move keyword and a move keyword. There is a bit of difference between simple move and move. Simple move takes the speed as a parameter and will move the character accordingly. On the top of that, the character will respond to gravity. And if we talk about move keyword, it is used for the absolute movement of the player. It is more preferable than simple move because it is more limited. We will use these keywords in C# for the required movement of our player in any kind of game. So let's move towards achievement systems. As per the name of content, achievements are recognized as awards. For example, we have a player in a game who has to jump across the obstacles. As it keeps avoiding obstacles by jumping, the counter keeps counting number of obstacles crossed. We can set a target ourselves, like if our player crosses 100 obstacles, he will be awarded with 10 coins or 10 points or something like that. I think this is enough to explain achievement systems. We will be going through examples of it as we move further in our course. Up next, we have a video and audio player content in Unity. Unity has a component called a video player and another one called audio player. Function of these components is to attach any video or audio file to any of the object being displayed in the game. It also gives the creator an opportunity to play the video or audio file in a loop, like back to back, or to play it on a specific occasion, for example a hooray sound when player jumps up to the final obstacle of the stage. Similarly, we have animations in 2D and 3D Unity. You can assign animation clips to the animation components and control playback from your script. The script is of course done in C# in Visual Studio. The animation system in Unity is weight based and supports animation blending, additive animations, animation mixing, layers, and full control over all aspects of playback. And what if we talk about animation state? It can be used to change the layer of an animation, modify playback speed, and for direct control over blending and mixing. And similarly, a very common example, a very common game named Ninja Side Scroller game. We will be developing this game further in our course. In this game, a character or a player sneaks through a specific environment while staying out of the eyes of the guards. We will take a brief hand on this game to increase our Unity skills. And up next we have menu animations content. It is simply about creating upfront menu of any game. What should be included in a menu of a game? Like let's start a new game, like go to the settings, like records or multiplayers, these kind of things. We will be learning to create these kind of components in this content. It is simple to understand. And in the end, last but not the least, augmented reality app development. In augmented reality, markers are images or objects registered with the application, which act as information triggers in your application. When your device's camera recognizes these markers in the real world, this triggers the display of virtual content over the world position of the marker in the camera view. And if we talk about image targets are a specific type of markers used in marker based tracking. They are images you manually register with the application and act as triggers that display virtual content. For image targets, use images containing distinct shapes with complex outlines. This makes it easier for image recognition and tracking algorithm to recognize them. And in the end, I would like to say that I have tried my best to explain every content of this course in short and complete manner. I am hoping that you guys are getting more and more interested in this course. Your reviews would be really helpful for me to cover up my mistakes so that we can move forward with more attention to get better and better outcome from this course. I will be hoping to see you guys in the next video where we will start from the very start by downloading and installing Unity and Visual Studio softwares, and then we will move step by step to achieve the goals of this course. Hello and welcome to another lecture of our course. In the previous lecture, I mentioned that we will be covering installation of Unity software. But before starting to prepare this lecture, I made up my mind to describe a bit about Unity 3D software. We will surely move forward towards the installation of Unity 3D in coming videos. For now, let's start this lecture with description of Unity software. Unity 3D is a cross-platform. It is a cross-platform game engine which is developed by Unity Technologies. Unity 3D is primarily used to develop both two-dimensional and three-dimensional games and simulations for computers, consoles, and mobile devices. It has been extended to target 27 different platforms. If we talk about Unity Engine, it targets following APIs: Direct 3D on Windows and Xbox One, OpenGL on Linux, macOS, and Windows, WebGL on web, and proprietary APIs on video game console. Additionally, Unity supports the low-level APIs: Metal on iOS and macOS, Vulkan on Android, Linux, and Windows. Let's talk about supported platforms in Unity. As I told you earlier, Unity supports totally 27 different platforms. These platforms are as follows: iOS, Android, Tizen, Windows, UWP, Mac, Linux, WebGL, PS4, PS Vita, Xbox One, Wii U, 3DS, Oculus Rift, Google Cardboard, Steam VR, PSVR, Gear VR, Windows MR, Daydream, Android TV, Samsung Smart TV, Nintendo Switch, Fire OS, Facebook Game Room, Apply, Apple ARKit, and Vuforia. Unity is the default software development kit for Nintendo, Wii U, and game console platforms. Lastly, we talk about supported programming languages in Unity 3D. Previously, Unity supported three programming languages: C Sharp, Boo, and Unity Script. But Boo was deprecated after the release of Unity 5, and similarly, Unity Script or JavaScript for Unity started to deprecate after release of Unity 2017. This means that if you want to excel in Unity 3D, you must have good skills in C# programming language. This is it from the lecture. In the coming lecture, I will be focusing on installation of Unity 3D software. It's time for you to take a look on system requirements and make yourself ready for more and more interesting stuff to learn. Till now we have been in introduction and installation processes, having lots of theoretical things that might have made our mind a bit boring. I still have to go for a video about installation process of Visual Studio. But in this video I have come up with something else. I thought to put up a video about what skills we are going to achieve at the end of this course. In this short video I will show you an example of a type of a game we will be creating after learning things. As you can see, this is a 2D ninja side scroller game. There is a player, a character who has to jump over the obstacles coming in his path. Two buttons to move forward and backward a player. Some awards and achievements are also in its path that give him energy. This is a very simple version of a 2D game. You will achieve much more after this course ends. You will be able to move this player in 3D environment after creating such environment. You will be adding scores, awards, menus and everything of this game, including animations as well. Once you learn these things, you will be trying your hands on many different ideas of game. I hope you like the video. From now we will move forward in our course and we'll try to learn all the contents completely. In this lecture we are going to explore how Unity works and how the files are being managed by Unity in any project. As you can see, after opening Unity, I have this dialog box in front of me. First of all, you see I have an option to sign in, another option to open any recent project I have been doing, and an option to create a new project. At the middle of this box, there is a space which shows list of recent projects by name. These projects are on the disk and we can change it to cloud and it will show the projects present on the cloud. Then here we have a learn option where it shows all the tutorials. Let's click on new to start a new project. First of all, we need to give a name to our project. Let's say project ABC. Then we need to select a location where we want to store our project in our PC. We can also choose here between 3D and 2D type of project. Then we have an add asset package button which shows list of all the downloads we have from the asset store. We can select any of them. Let's create a project. What it will do now that it will create and import all the required files to run Unity smoothly for our newly created project, and all the required files will be created on the project file folder location we specified. Now as you can see, the top bar shows the Unity version we are using, scene name which is whatever we have named it, and then the project name as project ABC. Then the platform we are currently building this project for. Here below in project we have an assets panel. Just right click here in assets and go to show in Explorer. Now let's see what we have. We have a folder with the name of our project. Then we have all these folders. Firstly, get into the project settings. It contains all the settings required to run a project. It is being managed by Unity. Let's get into library folder. This folder has all the files required to run a project smoothly. A temp named folder is also there, and Unity package manager folder as well, which holds all the packages we include into our project. In the last, we have an asset folder. It will hold all the assets we will import into our project and show it over here. First of all, let's create any file in Unity. Let's say C# script. Let's name it. You can name it whatever you want. Now let's go back to our assets folder. Here we can see asset folder now have two files of .cs and .meta. Whenever we create a file or whatever in assets, Unity creates a .meta file so it knows where and how to use this file. Now let me introduce you with Unity editor and all the different options and panels we have. So let's start with the top left. First of all, we have these 6 tool buttons: hand tool, move tool, rotate tool, scale tool, rect tool, and in the end, move, rotate or scale selected objects tool. These first 5 tools can be toggled by using Q, W, E or T buttons on the keyboard, and you can also select from this given menu as well, like this. What are their tasks? The hand tool makes you able to move the whole world around. Next, the move tool allows you to move any object in this world around. Similarly, the rotate tool allows you to rotate any object in the world in any given direction, like this. Next, the scale tool gives you the ability to change the scale of the object in X, Y or Z directions. Rect tool is for 2D images, and the last one provides you the functionality of all these three: move, rotate and scale tool. Next we have toggle tool handle position. Currently it is in the center. If we want to change it, if we change it to pivot, it changes tool handle and places it to the pivot point of active object. And for now we change it back to center. Then we have the rotation toggle. We can change it to global or local. Global rotation of the object is 0, 0 and local one is different. Then we have the play button. When you hit this button, it starts the scene and starts running the game, and also starts running on the scripts present in assets. A pause button is also there. We can pause the running scene, and then we have a step button as well to step it a bit forward. Then on the right side we have different options for services: the collab services, cloud build service, accounts. Then we have layers and layouts. In layouts, it is basically the style editor you want, 2x3 or you want 4 split. If you click on 4 split, it will create 4 different scenes over here, or you want any of these, scene will be changed accordingly. Layout can be deleted and saved from here as well. Here we have a hierarchy panel. In this panel you can see the active scenes currently in active mode. It also includes all the objects inside this scene. You can add another object or another scene from this create menu. By clicking here, you have all the different options to add objects in this scene. Then you have the properties of a scene bundled over here. It allows you to save the scene, discard the scene and discard the changes, add a new scene, or even add the game objects into the same scene. Now we have the scene tab. It basically shows us the virtual world we are building. Then we have a game tab. It basically renders what our camera is seeing right now, and this is what our camera is seeing right now. Down here we can change the different displays as well attached to our computer. We can also set different aspects of our displays. We can also set the scale of our screen as well. Then we have maximize on play button. For example, when we hit play button, the maximize on play button will maximize the screen. We can mute our audio as well. We can show and hide the stats of our game as well. Next thing we have is asset store. It's basically the store where you can download and purchase the assets from Unity store. Now we have in our editor, the other thing is inspecting. It's basically the properties of whatever we select over here, the objects. For example, I've selected the main camera. Inspector shows that I have selected the main camera, and whatever the tag is selected with this object, whatever the layer it is on, then all the different components attached to this main camera. Let's see what transform component of main camera has got. Transform component is usually attached to almost all of the objects in our scene. It tells where the object is placed in the virtual world. Then we have a camera component attached to it. We have different settings for this component. We also have audio listener. We can also add the components to this object by simply clicking add component button over here. We got a whole list of the components we can attach. We can either type over here to search the specific component, or we can just select it by scrolling up and down and finding the one. For example, this one. We have also gone through the project tab having assets panel. It can include all the scenes of all the projects, 3D models, and a whole bunch of stuff we can create while creating any game. In the end, we have console tab. Console tab is basically acting as the output tool, whatever we play inside the Unity editor. And we can get different kind of errors, warnings, debug statements printed over here. This was it from the Unity editor. In this lecture, we are going to discuss pros and cons of Visual Studio and MonoDevelop, and we will discuss which one should we choose as a new developer. In terms of stability, Visual Studio clearly takes the lead. Visual Studio has the capability of handling massive projects with a long history. On the other hand, MonoDevelop is not good enough in this regard. It hangs in there, but working on small projects you won't see much of a difference. In terms of resources, MonoDevelop takes the lead, while Visual Studio is a resource hog. You really need a current system with 12 plus GB of RAM to have it work properly and smoothly. It could be a real issue for some laptop bound developers. Anyway, MonoDevelop in resource point of view takes the lead. If we talk about features, Visual Studio wins it comfortably. It has ton of free and paid plugins that really extend its functionality. A popular example is JetBrains ReSharper, which is used to automate your coding routines, while MonoDevelop is way behind. Nevertheless, if you can't name a single external plugin you need, you should be just fine with MonoDevelop. Comparing styling, Visual Studio again leads. There are many more options to style your code and tweak it to your favorite look. MonoDevelop is no thrill, just business in this regard. It is also not bad if you are doing everything in the very start. Talking about documentation next, there is abundant documentation for both. In case of error issues, you might find Visual Studio more useful because it is being used worldwide and it is easy to find resources to your problems. Still, in both cases, virtually any issue you find has probably been suffered and solved by older coders. What is your final judgment? I think both are good, unbelievably. Both MonoDevelop and Visual Studio are good products. Since both are free to use, I would suggest you to take trial of both, test both, and then choose the better one you like. For macOS, Visual Studio Community isn't available, but still you can try Sublime Text and Visual Studio Code. They are both modest code editors and not full-blown IDEs. If you really can't stand MonoDevelop for some reason, you can give them a shot. That's it from this lecture. See you in the next video.